Hey, welcome to Stan's World. And tonight we're going to be making a nut for a 2.5 inch double lead left-handed Acme thread and on a manual lathe. So let's get ahead and get started on this little project. Okay, well, we've been turning, burning. We got all 4 of these things bored, rough turned, and counterbore. The reason I counterbore that is because here on my sample screw that I have, I made the sample screw. This fits the original nut, and I know that. So if I make mine to fit this screw, my sample screw here, because they can't take the screw off the machine. It's like 20 foot long. So anyway, that fits right in there. That's your tap drill size. And the reason I counterbore that thing, is so I dichum it up with bluing. When my threading tool comes out, when it touches that bluing, I'll know I'm right. Okay. And there's a trick I do on getting the double lead in these, and we're going to get to that. Okay, we are back here at the back of the machine. We're going to change out and get this thing in the low range of the gearbox, the high range, whatever you want to call it. Now what you got to do here is you got to pull this gear here out, and this gear here has got to go in. So to do that, you got to loosen up the set screw right here with the screwdriver, and also this set screw down here with the screwdriver. Okay, then you have to loosen this nut right here to make this idler wheel loose. Okay, then you simply pull this out, lock it back in, push this one in, lock it back in, and then you have to realign your idler and lock it back down. Let's have the socket turned the wrong way. Remember, when you're doing stuff like this, don't forget to work safely, wear gloves, make sure the power is off, because you don't want your fingers to be in there and this thing accidentally come on, okay? So, yeah, just make sure you have that done. Of course, this won't come on anyway. It's got the limit switch here, but still, I still have the power cut off. Make sure the gear's meshed in there good. And That's all you got to do to get it into the high gear. All right. Now then, let's go over here to the front and shift it and get it in the right gear. Okay, y'all, here is the gearbox on my lathe. Now, the gearbox on my lathe is metric and English, and that's distinguished by this F key. This side here is metric, this side here is English. Zoom down here, look at the scale. The scale here is metric. The scale over here is English. Now, this is the side you use most of the time. The top side is the side you use most of the time. That's most of the speeds and feeds and most of the threads you normally cut. And it goes by this gearbox selection right here. Let me get a little closer here so I can see. Like I talked about in the other video there, we slid one gear in and one gear out. And now we're down here. Okay. Now up here is what you normally use on top, and we're down here now. And like I said, we pull one gear out and we slid one gear in. If you go back up here, you do right the opposite. Okay, we're cutting 4 threads per inch on this screw, but it's double lead, so we're only going to cut 2 threads per inch, which is right here. So 2 threads per inch up here says G has to be in the number 1 position, and G is this monster right down here, and it looks like it's in the number 1 position because there's 2 and there's 3 and there's 11, so that will be 1. So that's correct. And then we come back over here again, and 2 threads per inch says the E has got to be in the number, can't hardly make that out, can we? In the number 2 position. I think that's what that says. Yeah, number 2 position. Now let's go up here to E and take a look and see what that says. I think that's E right there. Let's back up a little bit and see. Yeah, that's E. Right there, you got 1, 2, and 3. And it says it has to be in the number 2 position, so that's right there. Okay, so now we got E in number 2, G in number 1, and we're in the bottom gearbox. 2 threads per inch. So I'd say we're ready to go to the compound and set that bad boy up. What do you think? I think so. Okay, in this setup, we're going to set up the compound. It's very critical. When you're doing 60-degree threads, just OD threads, just regular threads, put them 30 degrees this way. If you're doing left-handed threads, of course you come around, the other way. 29 degrees this way. We're doing ID threads. Normally, if you're doing a right-handed ID thread, you come around this way. But we're not. We're doing a left-handed thread. So we come over this way. And not only that, we're doing an Acme thread, so that means it's only 14.5 degrees. A regular thread, a 60-degree thread, is 59.5 degrees included. Acme thread is 29 degrees included. So you set your compound at 14.5 degrees. Right there. And we lock her down right there. And that's where we're going to cut it. Next, we're going to line the tool up with the part. Here we have a Acme thread pitch gauge. As you can see, it's got little numbers on it. Now, you got to make your tool bit to fit this gauge. I just ground this on the hand grinder. It looks pretty good. You can see there, it fits right in there. 29 degrees included, okay? 29 degrees included. All right, now then, you get that like that on your angles. Okay, a little clearance on your tool there. Cutting brass and bronze, you don't want a whole lot of clearance. About 2 or 3 degrees is all you want. Now, see there that the end of this thing has numbers on it. And these numbers are your threads per inch. And we're cutting 4. So the end of our tool has to fit that notch right there. And let's see if it does. It should. I just ground it. Well, get it up here so I can. You can see pretty good fit there. So we'll line this tool up now with the part, and we'll cut some Acme threads. Let's do it. All right, we got the tool reground. Got where we wouldn't cut on one. We reground it up and we reset the tool. Now we're going to check the tool and see if it's square with the part. And to do that, we need the old trusty Acme thread pitch gauge. And they got numbers on it, 1 through 4. That indicates threads per inch. We're cutting 4 threads per inch, so we got our tool set on 4. See right there. All right, now we lay this tool up on here, square with the part like so, and bring that in there and make sure that angle is right on your tool. And it is. So we are ready to touch. We are ready to touch and we are ready to set our 0 points and start cutting threads. We got our compound set on 14.5 degrees, and we got her set up over here on 2 threads per inch. We're cutting 2, but we're double lead. So let's cut the first lead. Let's get on it. All right, let's cut some threads. Let's cut some threads. Now we're going to go into reverse. Make sure we miss it. Come back to 0, and we take a cut. believe we got the first lead cut. Thread depth is supposed to be half of the pitch. So the pitch on 4 threads per inch is 1/4 inch, and half of that's 8 plus 10 thousandths would be 135 thousandths deep on the thread. So I'm making about 140. So let's rotate the chuck and cut the other lead. Remember, safety first. Hit the power, put it in neutral. Alright, let's bring this up here where that line is on 0 right there. And let's rotate this chuck. Now you can only do this trick if you got a cam lock truck. A screw-on chuck will not do this. On this jaw, and lift it right off. And let's blow it up a little bit here. And let's rotate it 180 degrees. Our other mark we got up here. And let's put the chuck back on. And it's just as easy as that. Again, repeat and do the exact same thing again that we just did, and we will have a double lead in our block. Put it back in low gear. Get the power off. Go back to 0. Past 0 actually. Cut another thread. When you get through here, we'll cut a thread right in between those threads. Exact thing to do. There on 0. And there it is. Thread in between thread. Let's do it again. And again. All right, we're getting there. Okay, y'all. Well, we got one real close to being done. I think it's done. Still got to turn the OD on it and face it off. But let's see if the screw goes in there. Well, that's that. You can see it screws in quite well. Very little slop. That's that. Tell you what, it's a lot of work in one of them old brass nuts right there. I mean, the bronze is a lot tougher. We used to make them out of brass, but we started making them out of bronze. Bronze is a lot more abrasive on my tool, and I have to grind, sharpen my tool more. I had that little problem tonight. But those things are tough. I mean, I've got it down to almost an art. I haven't quite got my numbers down exactly yet, so each one of them pretty much has to be worked in. They require a lot more clearance than regular bolts do, those double leads do, so you know, sometimes when you figure your pitch, your actual hole is going to be a lot bigger before you're finished, before you get that screw in there. So, but we get her done, you know. Maybe you learn a little something there. You know, like I said, you know, you got that cam lock chuck. You can always, you know, rotate your chuck to do that. If you didn't have that, I'd have to do it with the compound. There's no other way I can do it unless I put it on faceplate some way and, you know, be able to rotate it exactly 180 degrees. But it is what it is. It's fun making it. More fun making the video. Y'all don't forget to like and subscribe, and stay tuned for something. Next crazy job that comes to the shop. Who knows what that might be. Have a wonderful evening, and God bless. Bye-bye.